What's up, everybody? It's Professor Cooper here. We're going to do some more material today, and this first video for the week 6 bonus material is all about a couple of data techniques that are really useful. One of them is creating your own function, which means you can really do a great deal. Everything that you've done so far, pretty much everything that exists inside R as an object is a function. That includes functions, that includes operators like the subsetting operators, like the math operators like plus, minus, the asterisk for multiplication. All those things are actually functions, right, underneath. So I'm going to briefly teach you how to make your own function, which can be super useful. And then I'm going to teach you some vectorized ways to apply functions to larger data sets and things like lists, where you've got, let's say you've got a bunch of data sets and you want to run some mega function on everything, and you're trying to process a lot of information in a very short period of time. You can combine your ability to make your own function and your ability to work with lists together through things like apply functions in base R, but even better, I think we will be using some of the functions from purrr, and I'm going to introduce map, the map function, which is like lapply. It's a very close sort of cousin to that. Okay, so to do this, we're going to need ggplot2 and purrr, which is where the map function comes from. And then recursive is useful, I think, later on when I have some more examples. There's some really good data sets inside recursive to sort of play around with this. Okay, so first, functions, making your own functions. What do we need to do to make this happen? It always starts with, and I'll type this out and then we will go through the example. Let's say that we are naming this. It starts with function, and just like any function, the function starts with open and close parentheses, but then it also includes curly braces afterwards, okay? And then you'll hit enter once, and this is the basic structure of every function, okay? Everything that you've used, the underneath part of it, starts with this. What goes inside here is going to be the arguments that you need to make the function run, okay? So let's say the answer is A. We're going to call it A, and that's all it is. And it doesn't really matter what we call it. Normally it'll be something like X and Y, let's say, something like that. So you'll need two parameters here, two things to define in order for the thing inside of the function to work. Now we need to define what this inside function is going to be, and let's just say we call it addition, and it's going to get x plus y. Very simple. Okay, so this is where this is how you would start. What's the actual mechanical component of the function here. And then the final piece that you have to have in order for this to work is you have to print the thing that you want as an output. Because if you don't, it will perform the function and you won't be able to go find it. You won't be able to go grab it. So you want to print the thing that you just created. Okay, print addition. All right, and that's all of it. That's the total sum of what a function would look like, and then you would name it something, like adding, as in like adding machine, and call it a day. And then you could use adding. Okay, run that, and then if I type now for the object adding, check this out. It's now a thing in the global environment All right, and if I finish that and I open the parentheses, look, it knows that I need an x and a y. Okay, and like any function, I can just type two numbers, in this case, for x and y, and it'll know what to do with them. So the adding machine performed the function I wanted. It added 2 plus 8, and it made 10, and bada bing, bada boom, we've got a thing. All right, now, and I've given you another example here where it was marginally more complicated math. We're squaring instead of adding. And this time it's a function for x and y. And it's going to be x squared plus y cubed. And then I print the value because I called it value. Those things have to match, right? I'll run this. And then I will do 4 times 8, or sorry, 4 as x and 8 as y. And so that is 4 squared, which is 16, and then 8 cubed. And so to sum as 528. All right. So these are very simple functions, but you can put 100 lines inside a function. You can do all sorts of crazy things in a function. And you can build, let's say that you have sort of a data management need, and it requires about 7 to 10 to 15 lines of code. And then you might want to run it on multiple data sets. And assuming you have the appropriate generalizable code inside this function, you could, in theory, save all that code. Instead of running all those lines a bunch of times, you can save it all inside this function wrapper. Define the parameters you would need to feed it in. Normally, it would be whatever the data set is, and maybe an additional piece of information or two. And then you can run that, and you can do a lot of things in a very short period of time, and you don't have to repeat all the code again. Now, the thing I'm going to show you with mapping is that it can apply this sort of recursively in a vectorized way over a series of pieces of information in a list. So if you have a series of data sets that all come together, the disparate maybe, and you bind them in a list, because you can bind anything in a list. It's flat, it's got length, but it can take any class, right? It can take any class object. You can then perform iteratively with the mapping like an lapply function, which I haven't introduced, but it's the same as this. It's just base R. You can do this in an iterative fashion and do a lot of things in a very short period of time. Okay, I'm going to make one more, and then we are going to apply it to the world income inequality data set, and you're going to see what happens. Okay, so I'm going to make, it's called basic. It's a very basic function. It's going to require an argument called data, and I've defined what happens. So data sub gets whatever the data is, so the input, and then select starts with the letter Q, and then print what's left. Whatever comes out, that's what we get. Okay. If you recall, there are a few variables that are quintiles in the world income inequality data set. And there are actually a couple of others we'll find that start with Q as well that aren't just those quintiles. But we're going to take this and apply it to the world income inequality data set. So we're going to run it. And now we're going to use the map function, and we're going to use split first. I should show you split, what split does. Split's a base R function. There's a group split for dplyr that's brand new, basically, that's being, it's in the quote-unquote experimental phase as we speak in October 2020. And it takes a data frame and splits it up into lists based on the groups variable of a variable. So if I say split by region, it's going to do that, right? So right here I do that. And you've seen this data set before, but now you see we've got 5 separate tibbles that are elements in a list, okay, for each of the regions, from the UN regions, from the World Income Inequality Database. Okay, so this part breaks apart the WID into a list just for the purposes of using map, right? Like I can't use map on the database as it exists normally because it's not in the list. Okay, so I create the list in order to use it. But I'm going to create the list and then I'm going to use map basic. So basically, normally you would pretend like this was already in a list format and you needed to use map. Here we're actually sort of making a list so that we can use the function, right? If that makes sense. Okay, so I'm going to run this and it's going to run the basic program. So map says I want a function that I can apply to the list that is WID, or I could have just put WID list in because I saved it here as a list of the 5 regions as little data sets, little tibbles. And you can see everything that started with Q came back for each individual subset, each individual element from the list, which is pretty cool. Okay, so this is sort of proof of concept, if you will. So you can apply this in any way you want with your own functions. All right, let's see. So I'm going to do one that's a little bit more complicated, but not by much. I'm going to take WID, I'm going to split it into regions again, but this time I'm going to run a quick linear model on it. Okay, now this is pretty simple, this is pretty straightforward. You may or may not have seen linear model code before. I also teach stats classes, obviously from quantitative social science, but also at other universities like University of Michigan in the summer at ICPSR. And so we've got a basic linear model here, and a linear model is just a function. So we're going to apply the map to, we would have a tilde here representing feeding into the function. We're already in the list because we've piped in from the list, so we don't need to set the list on this side. And the function for linear model is LM. We're going to do Gini reported as a function of the GDP per capita, and then you have to name the data for that linear model function. And we use the period because we're referring back to the inherited form of the object. So this is the dependent variable tilde independent variable for the linear model function and given these data. Okay, and then we can map into yet another function that is a summary based on that. So we could do these individually, and then we can also get a summary, because normally you don't look at the linear model directly. Once you run that, you actually look at the summary because it provides you most of the information that you want, the statistical information you want from running a linear regression model, OLS stuff. Okay, so we're going to go through this. This is starting from scratch, and then we use 2 map functions in a row on the list. And it runs this once per region, for Oceania, for Europe, for Asia, for Americas, and for Africa, right? So you can see how this can build, and you can run this on what comes after the map function and the list that would normally come here if you weren't piping in is a function of virtually any variety, so long as, now keep in mind